Okay, so we're studying obviously for our probability review. What is a probability?
The chance that something happens.
The chance that something will happen, or the chance that, or the result of an event, experiment, which is called experimental probability, right? Okay, number one, a number cube is rolled. Now that's the same thing as a dice, exactly. How many sides? 6. Okay, find the probability of getting a multiple of 2. Okay, what are multiples of 2? 2, 4, 6. It's the same thing as even, isn't it?
Yeah.
So that's 3 out of 6. So therefore, ooh, I could ask you for the sample space too. Yeah, I might write that. So on the test, I might say sample space. Give the sample space. Remember, that means you have to have a bracket, and you have to write the sample space of the possible outcomes. The possible outcomes are 1, 2, 3, 4, 5, 6. That is the sample space. You have to write 2 brackets, and you have to write commas. Okay, I can't make my bracket. Let's try it again. Hey, I did it. No, you have to do brackets. But they don't have to be wonderful artistic brackets. Please write this down. Okay, write your response as a fraction, decimal, and percent. Ooh, tricky. So I should see on your answer 3 out of 6. Why? Because 2, 4, and 6 are the answers. So, should you show any work? Yes. Show this. Okay, now we do reduce to 1/2, and therefore fraction, decimal is 0.5 or 0.5, and then percent is 50%. All right, so fraction, decimal, and percent, and sample space, if I ask you for it. So see, if I asked you for sample space, I would give 4 different points on this. Okay, a spinner with 6 equal-sized sections, marked FACTOR. What is the? So that should have an is there, shouldn't it? Is marked FACTOR. What is the theoretical probability of landing on a consonant?
No, it should say is marked because it says a spinner with 6 equal-sized sections. Yeah. It should have an is.
It should have an is. Yes, it should. A spinner with 6 equal-sized sections is marked. Now, if it didn't have an is, then it would have to continue the sentence. Ask your English teacher. I'm right this time. All right. I like English. I'm not bad at English, I think. I can even SPELL on OCCASION.
Spell.
Nobody got it?
Spell really fast.
OCCASION. Occasion. I can even spell on occasion. All right. What is the theoretical probability of landing on a consonant? So somebody asked me how many consonants there were. Now, you did not need that information. You just need to see how many out of 6 are consonants. So we've got F, C, T, and R. Right? So I should see that somewhere on your paper. If you have a highlighter, you could use that. And so that's how many out of 6? 4 out of 6. And yes, you have to reduce it. If you don't reduce it, accelerated math, I'm taking half off. 2/3. Any questions?
Oh. Got it. Right.
Half. I'm not taking your health away.
Do it.
Shh. Okay, a spinner is spun 100 times. Good for the spinner. The results are shown below. By the way, who got 100% so far?
Not me. Yeah.
The spinner is then spun, the same spinner, then spun 100 times. The results are shown below. So this is an experiment, right?
Right. No, it isn't.
So I could say, what kind of probability is this? And you guys would have to write experimental. I might do that. So study. What kind of probability is this? And you're going to write experimental. Okay. So, of landing on a consonant. So, consonant is this one, this one, this one, and this one.
Oh, we're doing continent?
Well, that's what it asked. It asked here for consonant, right? So, therefore, what do?
We add them.
Very good. We add them. What did you guys get? Because I don't feel like doing it. I'm lazy.
54.
I'm lazy. You guys do the work for me.
54 over 100 produces 27 over 50.
Cool. So 54 over 100, which reduces to 27 over 50. Thank you very much. Now my question is, what if they could have tricked you. I could trick you. It could be a tricky McTrickster problem, and it would ask you, it would say, okay, the spinner is spun 100 times, the results are shown below. What is the theoretical probability? What is the theoretical probability of landing on a constant?
2/3.
It's 2/3 still. Because the theoretical probability would not use the experiment. It would not use the data. Tricky McTrickster! Okay, did everybody write this down? Everybody good? Everybody good? Okay. A survey okay, another typo. I didn't write this, haha. A survey at Canyon High School showed, oh, and you guys don't have an A, do you? Because the hole punch messed it up, right?
Yeah.
A survey at Canyon High School showed that 6 out of 11 students help siblings with homework. Isn't that nice? Predict the number of students who help siblings with homework if there are 1,200. So yes, you could do this in your head, but you're not going to because you have to show your work. 6 out of 11 equals question mark over 1,200. Okay? So, we can multiply and divide, right? We could do it that way. Or we could see how many times 11 would multiply, but it doesn't work out, does it? So we're going to have to probably cross multiply is better. So we get 6 times 1,200 is what?
72.
Right, 7,200, very good, equals 11x. And then we divide. We're not going to get an even number, are we?
No.
Oh, no! And what do we get?
654.54.
Okay, so x equals to 654.54 repeated. Okay, so would you estimate? Would you round up or down?
Up.
Up, because this is a 5 or higher. So 655 students we would expect. Do you have to label your answer? Of course you do. Let's highlight with fuchsia. Is that a fuchsia or pink? What is that? Is fuchsia the same as pink?
Red?
Hey, you guys can ask your art teacher. Who has art teacher? That's your job. Ask your art teacher, and then the rest of you are going to ask the English teacher if I'm right, and she or he's going to say yes. Okay. Shh. Did I move too fast? Okay. One of the 5 equal sections of a spinner. How many sections? How many sections? It's yellow. If the spinner landed on the yellow section 15 out of this many times, compare the theoretical probability with the experimental probability. Okay, who can tell me how to do this? How many can help me do this? Yeah.
So put 15 over 85.
Right, and we're going to reduce that. Now, is that the experimental or the theoretical?
Experimental.
Right, that's the experimental. So 3 over 17, correct. Okay, so that's 3/17. And then what's the theoretical?
1/5.
1/5. Now, usually all they want you to do is say which one's bigger.
Divide 3 by 17 and divide 1 by 5. Okay.
Exactly. Let's get a decimal. So who has a calculator out?
I do.
So since we used our calculators, we found out that this one is slightly more of a chance, right? So theoretical theoretical, yeah, good spelling, Mr. Pat. Theoretical probability, prob dot, since I'm lazy. Theoretical probability is slightly higher. Than what? Slightly higher than what? Exactly. Than the period. No, I should do hyphen. Experimental prob. Okay, I'm done. That's enough. You guys get it?
Yes.
Awesome. Next. Can I move? Can I move?
No.
Yeah, the answer is that the theoretical probability, 1/5, is slightly higher. It's a little bit higher probability than the actual experiment showed. But they're close. All right. Now, if we do more times, do you expect it to get closer or farther away than the theoretical?
Farther.
Closer, closer, closer.
What?
A co-ed dodgeball team, that means that there's males and females. How many females should be added to the team so that the probability of randomly choosing a female player is about 65%? Okay, now this is tricky. We had a problem just like this on our Quizalize, right? Because when you add, then the total changes, right? So, don't forget that, because now we have a denominator of 14. But if we add 1, the denominator is 15. And that would be 8 females out of 15. So we need calculator help. 8 out of 15, 9 out of 16, right? 10 out of 17, 11 out of 18, 12 out of 19, 13 out of 20. Uh-oh. Hey, I can do, that's easy. That's exactly. You know how I know?
How do you know?
Because if you divide both of these, by 2, what do you get? 6.5 out of 10. So that's exactly 65%. So how many females did we add here? 1, 2, 3, 4, 5, 6. So it's actually 6. Why did it say about how many? Oh, it didn't say about. How many females should be added? So that the probability is about. Yeah, why did it say about? There should be no about, because it was exactly.
Tricky.
Yeah. No about. All right? 6 females. Okay, I'm running out of space there. 6 Okay, ready? Okay. A college student needs to buy bedroom furniture for her apartment. She plans to select one item from each of her 4 boredoms, her 3 boredoms, her 3 lanterns, and her 5 drapers, and 4 night tables. Alright, so there's a whole bunch of different furniture stuff. Okay? Find the total number of outcomes. Okay. So 4 times 3 times 6 times 6 times 5 times 4. Alright, so easiest way is to combine easy ones. I don't know, 12, 30. So 12 times 30 times 4. Yeah, I think that's what it's going to be. 1,440. Do we trust Michael?
Yes.
Did somebody else do it? Somebody else is doing it. Okay, good. So there's 1,440 different things. But are there really going to be 6 different types of lamps and 5 different kind of desks at the store? I don't know.
I need
Beds in a single bedroom.
I know.
Right?
Well, maybe this person has 4 bedrooms in the apartment.
Yeah. That would make sense.
Yeah, right. Okay. All right. A basket contains red, green. Did I move too fast? No. A basket contains red, green, and yellow. An apple is selected at random. Okay. So the probability of red is 25 and the probability of yellow is 13. what is the probability of green?
Add
It's
25
2 over 5
and
and 1 over 3.
then just
All right, we just did this problem. I don't think it's really makes the problem any better if you have to find a common denominator or not. So there we have it. So 8/15 and 3/15. So now, what is the probability of green?
4/15.
4/15. Very good. And how did you get that?
I added 8/15 with 3/15 and
Makes 11. Right, and there's 4 left over. Yep. Any questions? So since I made it so easy, you're going to spend 2 seconds to go 8 plus 3 equals 11, and then you're going to go 15 minus 11 equals 4, just to make me happy. All right. The experimental probability of accordion landing on heads is 23. If the quarter landed on tails this many times, how many times was the coin tossed? What do you think?
Wouldn't you have to add them?
Wait a second.
Yep. So that is 71, right?
Yeah, 71.
We added them together 71 times. What?
With number, I just looked back at number 8.
All right, experimental probability is 2/3. The quarter landed on tails, 48. So tails was 1/3. So we need to multiply by 3. Ooh, that's awesome. This is a cool problem. Write it down. It'll be your exit ticket. That's why I told you guys not to pack up. So there were 144 total, right? How many times was the coin tossed? Yeah, 144 times. Because tails was only 1/3, and then we don't need to multiply times 3. Last one I'll do with my next class. Did you guys write that down?
Yes.
Okay, so study this on the YouTube. It's not Minecraft. Chris rolls a number cube labeled 1 through 6. Well, that's what number cubes usually are labeled. Number cube's another word for dice. Okay, he also spins a spinner with 5 equal sections. Okay, so what is this called? What concept is this? Excellent. Compound probability. Let's give him a hand. That was terrible. Compound probability, very good. So that means you're going to be multiplying 2 things together. All right? First event and the second event. So both numbers are even, he wins. Otherwise, Adriana wins. Find the sample space and then find the probability that Adriana wins. Sample space. That's a lot of sample space. My goodness. Number cube and 1 through 5, that's going to be 30 different things to write. Oh. Okay, we gotta write all our sample space out. I didn't write this quiz. Alright, you guys ready to write your sample space? Here we go. Dark blue. Now remember, your sample space has to start with a bracket. Okay? Then you're going to do all the different things that you could have landed with a 1 first. So 1, and then spun a 1. So 1 and 1. God, that's going to look like an 11. Let's do 1-1. Okay, then we're going to do 1-2, and then 1-3, 1-4, 1-5. Okay? Alright, then what? 2-1, 2-2, 2-3, 2-4. I don't think I'm going to make it this long on the test. Hey! I'm messing it up just even. Okay. And then you would have to write 3, 4, 5, and 6. Oh my gosh. Alright, let's just pretend like we did it, shall we? Or do you guys want to make me do it because it's my job? Oh, you guys are so mean.
We're about to
You
get.
guys are
If he
so
doesn't, so do
mean.
you.
Okay, 3, 1, 3, 2. See, I can't even do it right. Look at that. Oh, this is so horrible. This is gonna go on YouTube forever. No, I'm never gonna be able to get away from my past when I didn't want to write this. I know, my students were mean to me. They bullied me. That's the word everybody uses now.
Yeah, Diego.
You guys bullied me.
Oh yeah, that's you.
I can do it. You guys don't scare me. I can do it. And then what are you gonna say, huh? Then what are you gonna say? All right. Yeah, right. Okay, 6, 1, 6, 2. Well, you have to write it too then. Hey, I bully you right back. But 2 wrongs don't make a right, do they? All right. How about this? I won't make you guys do it. Hey. You don't have to write it all.
We already did.
Okay. So let's look at this. Now that we do have it written, if both numbers are even, so let's see how many of those there are. Well, it's not going to be any in the first row. It's going to be 1 here, 1 here. I can predict it. What do you think? It's going to be 2, 4, 6, isn't it? Yeah, if both numbers are even, he wins. So how many times does he win? 6 out of 30, right? 6 out of 30. Okay, but what were they asking? I didn't look at the final answer. Find the probability that Adriana wins. So that this is the probability that he wins. So Adriana wins is the compliment. Jordan, ding ding ding. Let's give her a hand. Good job, Jordan. Okay, so the complement is, well, actually we could reduce it first and then do the complement. So it's 1/5. Very good. So that's easy. So the complement is 4/5. Chances that Adriana will win. That is the answer. Because these are the only chances that he will win. 6 out of 30, which reduces to 1/5. And then all the other chances, which is actually 24 out of 30, which reduces to 4/5, is her chances. Get it? Okay, I'm not going to make you write that much on the test, though, because I'm not mean. Well, let me improve my bracket. That's a terrible bracket. If this is going to be on YouTube, I don't want to disappoint my subscribers. Hey, not bad. Not bad. All right. Bye, YouTube.
Bye.